In this section, we want to look at modeling right triangles. First of all, what is modeling? Well, we're not getting out Play-Doh and making triangles out of it. Modeling means modeling a real-world situation, okay, or word problems. So, example 1, here's our picture. We've got a rain gutter is to be constructed of aluminum sheets 15 inches wide. So here's our original sheet of aluminum. After marking off lengths of 5 inches from each side, the sides are bent up at an angle theta. So seeing our figure here, we've taken our sides and bent them up to look like this. Express the area of the opening as a function of theta. So we'll go back over here. I'm just going to draw over this, and then I can pick it up and take it to the next page with me. That's pretty bad. Let's see if I can do that a little bit better. There we go. So here's theta. That's theta. And each of these pieces are 5. And so there's our picture. And what I'm going to do is I'm going to take this piece over on the left and make it into a right triangle just by dropping straight down. Actually, no, I'm going to do it over on the right because that's what I've got in my picture on my paper. There we go. And in that case, if we look back, we've got that this length down here, we're going to call it B. And this length, I'm going to call it H. It might not go exactly along with our previous picture, but that's okay. And then we've got a hypotenuse of 5. Okay, so we've got this triangle where theta is right here, and our legs are B and H. How can we find the area of the opening as a function of theta? Well, we know that area is 1/2 base times height. And that's why I called this B and H, because it's base and height there. Right? Okay. Well, let's take this triangle and let's solve for the height. The height, well, no, let's do it this way. If we want the height, that's the opposite of theta, so we need to use sine. Sine of theta is opposite over hypotenuse. There we go. So H, if we multiply both sides by 5, is 5 sine of theta. Okay. Well, what could we use for B? How can we find B? Well, B is the adjacent, so we can use cosine. So adjacent over hypotenuse, B would be 5 times the cosine of theta. Why didn't we use tangent? Because then we'd have B and H. We wouldn't have 5. We couldn't do that. We could have used secant or cosecant, but why? Sine and cosine are very straightforward. Those are the ones we usually stick with, if at all possible. So now we can find the area. the area is 1/2 the base times the height. And we found that the base is 5 cosine of theta, and the height is 5 sine of theta. Simplify. We've got 1/2 times 25 times sine theta cosine theta, and half of 25 is 12.5. So we can, or so far, we've found the area of just this triangle under here. Oops. Okay? Now that is the same as the area of this triangle and this triangle. So that gives us this area and this area. And all we need now to find the area of the opening is the rectangle. Okay? So to find the area of the rectangle, I'm going to call it R and go back up and call that A of T. Well, that would be the base times the height. So the base is 5. And the height we already found to be 5 sine theta. So that gives us 25 sine theta. So to find the area of the whole thing, trying to find a different color here, we're going to take the area of our triangles. We've got 2 triangles, so multiply by 2, and add that to the area of our rectangle. So we'll have 2 times 12.5 sine theta cosine theta plus 25 sine theta. And we can simplify that a little bit. 2 times 12.5 is 25. So 25 sine theta cosine theta plus 25 sine theta. And you could factor something here, but you don't have to. And so there is our area. Now, the next step asks us to find the area of the opening for 30 degrees, 45 degrees, 60 degrees, 70, and 75 degrees. So I'm just going to go back over here and grab my area. And we're going to put in first 60 degrees here, or nope, first 30 degrees in for theta in each spot. And I'll work this first one, and after that I'll just tell you what the answers would be. So this first one, we'd have 25. Sine of 30 degrees is 1/2. Cosine of 30 degrees is √3/2. And then we have 25 times sine of 30 degrees, which is 1/2. That would give us 25 √3, just multiplying straight across the top, and 2 times 2 is 4, plus 25/2, which is approximately 23.33 square inches. So we'll do the same thing for an area of 45, or for angles of 45 degrees, where you'll plug in root 2 over 2, and we get 30.18 square inches. Go ahead and put this down. And then 60 degrees. We get 32.48 square inches. And then the last one, 75 degrees, gives us 30.4 square inches. And then part C asks us to find the angle, what angle theta would make the area the largest. So what would allow the most water to flow through the gutter? And so what we could do with that is go over to Desmos and graph it, and I'm just going to sketch it on here. We would end up with something that looks something like that. And in Desmos, you would graph it as y equals 25 sine, and you have to put x in parentheses, and then cosine x plus 25 sine x, okay? And you can find your maximum point here, and it is 32.48. So it looks like for an x value of 60, that's essentially our theta, because we used x in Desmos for theta. So for an angle of 60 degrees, that would give us the largest area of 32.48. Example 2, we're going to find the width of a lake. The irregular blue shape in the figure represents a lake. The distance across the lake, A, is unknown. How does a surveyor find the distance across a lake if he doesn't want to walk it? And yeah, that would be hard. So to find this distance, a surveyor takes the measurements shown in the figure. What is the distance then across the lake? So we've got an angle here that's 24 degrees, and we've got how far the surveyor is from a spot directly across from the lake, 750 yards. And if we have those two pieces of information, then we can find the distance across the lake. We've got theta, we've got the opposite, and we've got the adjacent. So we need to use tangent. Tangent of 24 degrees is opposite, that's A, over the adjacent, 750. Multiply by 750, and so A is 750 times the tangent of 24. Make sure your calculator's mode is in degrees and stick it in. The distance across the lake is 333.92 yards. Don't forget your units. Angle of elevation and depression. Basically, an angle of elevation and depression, we can create right triangles out of those. So if your horizontal is like this, then an angle of elevation is up from the horizontal. An angle of depression is down from the horizontal. An observer on the roof of a 40-foot building measures the angle of depression from the roof to a park bench on the ground to 24 degrees. What is the distance from the base of the building to the bench as measured along the ground? Okay, so we've got a building. There it is. Yeah. And we've got a park bench. This picture is not to scale, and yeah, I'm not a drawer, but you get the idea. And here is our grass along the ground. And we want to find the distance from the base of the building to the park bench. So that is that distance along the ground there that I just drew. Our problem says that the observer standing on the roof looks down at the park bench. And, well, he's not standing on the roof. He's laying on the roof, so he can be at the very top of the roof because we don't have the height of the man. Yeah. So, let's see. He is laying on his belly on the roof. There we go. And looking down at the park bench for some weird reason. And it says that the angle of depression from the roof to the park bench is 24 degrees. So what we're talking about here is that if we draw a horizontal up here, then the angle from that horizontal down to the park bench is 24 degrees. And we were told that this is 40 feet. So what have we got here? Remember back from high school, parallel lines, alternate interior angles are congruent. Yeah, you kind of have to remember this stuff a little bit. This angle and this angle are going to be the same. So this angle is 24 degrees. We've got the adjacent and we've got the opposite. So we can use tangent to help us find the distance from the building to the park bench. So tangent of 24 degrees is opposite over adjacent. Multiply by D. And to get D by itself, we need to divide by tangent of 24. Put that in your calculator, 89.84. We're in feet. And so there's your introduction to modeling right triangles.